Hey guys, let's do the problem 238 Leetcode. It's been a while since we exercised the right part of our brains. So as you know, the left brain, right brain, and the one side is supposed to be analytical, one side is supposed to be artistic. And I've been using a lot of artistic side and I haven't used the analytical side in a while. So I thought it might be a good idea to do this problem, Leetcode 238, the product of array except self. It's kind of a, I would say, low-hanging fruit, even though it has been characterized as medium. And so, and we're going to do that this in C++ this time. And this is first for our channel because we have never done a problem in C++. And C++ is an interesting language as well, I would say, because it has a lot of these concepts which are very intuitive when it comes to the real world. So anyway, let's take a stab. I don't want to keep the monologue going. And so let's read the problem. Given an array nums of n integers where n is greater than 1, return an array output such that output I is equal to the product of all the elements of nums except nums I. So as you can see, all he is asking is that every element of the input array is converted into the product of the remaining elements. So basically you multiply all the numbers in the array except by itself. So for example, let's take the example 1, 2, 3, 4. So if you don't take 1 into account, 2, 3, 4 multiplication will be 24. Now let's take the second element should be except 2 multiply everybody. So 3 times 4 times 1 is 12. Now in this case except 3 you see it will be 8, and in this case except 4 it will be 6. So that's the idea, and so it doesn't sound like too hard to understand the input output and what is expected from us. The constraint is given is it's guaranteed that the product of the elements of the any prefix or suffix of the array, including the whole array, basically none of these products will ever be not fitting in a 32-bit integer, which is a good news for us. Now please solve it without division and an ON. Now why is that the case? Because otherwise that becomes a trivial problem, because you could just walk the array once, multiply everybody, so you get the product of the whole array, and then you walk it again and divide by itself. So basically you get rid of that element and then you get the desired output, but that's not what is asked for. He's saying please solve it without division and in ON. That means you shouldn't do any walks within the walk. So it's not like you have a trillion element array and for each of that you're walking again another trillion. So no walks within a walk. So that's like I and j for each I and for each j, where I and j both go to the whole array. So that's not what is asked for. And he's saying constant is space complexity. So no extra space should be allocated, and he's saying that's in follow-up. But maybe you know what? Let's try to do the final problem itself rather than the follow-up. So anyway, so what is asked is that let's go for, we have to return an output array. So we definitely need something known as this kind of thing, and this is saying, hey, I need a vector of ints, and I'm going to call that as output vac. And so output vac would be of size what? It's going to be nums.size. So that's cool. Now first thing we should do is make sure that each element of output vac is initialized with 1. Now int I equal to 0, what is the logic behind this thing? Like, why should we go? Because you know what, multiplication doing by 1 doesn't affect anything. So I guess just like the sum doesn't is not affected by adding with 0. Similarly, having 1 doesn't cause a lot of issues for us. So we'll just say output vac I equal to 1. So that's good. Now, what is the idea we are going to use here? So now look, let's think about it. Now, when you're walking the array, idea is that, remember, I think this kind of gives us a good hint. It's saying prefix and suffix here. See the prefix. So the prefix is, I would say, like for example, if you take here, let's take a middle element like 3. The third element of the output array would be the product of all the elements, that is the prefix array on the left of it, times the product of all the elements on the right of it, excluding itself. So let's tackle these problems like one by one. So first thing is, we are going to walk it in so how about if we walk the output array twice, where first time around we get the prefix part and the next time around we get the suffix part. So it's like saying that when the first time around we walk, what we would have here is actually just 2. Why? Because it's just 1 time 2, and the next time around when we walk other way around from the backward, then finally we'll get 8 here. So let's see how we can do that. So what we're going to do is we're saying, so remember, now we need an extra variable temp, which will store the value which we put in the output vac array. So it's like the temp holds the product of all the elements before that element. So that's why you're seeing here, we are saying now we are updating temp. So we're saying temp equal to output. Here we're going to say temp. So basically all we need to do is we take num_size, which is the input array. How about that? Does that make sense? So as you can see, what would have happened is the nums_i is being used after the output vac I is updated with the previous value of term. So that means we never get the ith element in output vac I at this point. So imagine if you were at the third element, you would be having 2 here. So what you're assigning here will be 2, and then temp would be then updated to basically 6, because that's when you will actually use the third element. So here it is 6, and that is why when you work on the last element, you will get assigned 6 here, and then we will basically run out of the we will basically fail in this check I less than num_size, and we'll get out of the loop. Now let's do it for the other side. So again, reset temp to 1. So it's kind of lagging and leading kind of concept. I think here the concept is you're lagging here, right? Because you use nums_i after you have already updated the output vac with the temp. So you're not actually using nums_i in the output vac I place, right? So that's the idea. Now here again, it's a very simple concept. We'll start from the end, the other end, the right end. So here that means it should be what? nums.size. C++ nicely gives us the size of the array -1, which would be the last element by if you go by the indexes, and then here will be I greater than equal to 0, and we are basically walking backward. So you have to do I minus minus. Now, what is the concept here? It's pretty much the same thing, but remember, we don't want to miss out on what we already had there. So that is why only difference is that you have to do this. Like for example, you need to multiply with the existing output vector, unlike in this case where we were starting from scratch. So otherwise what would happen is you would get the right side and the left side will be lost. Otherwise, besides that little technicality, it's pretty much the same loop. And once you are done, all you need to do is return output back. Return output back basically. Would that work? Let's take a look. And so here we have a problem. And what is the problem? Is saying error expected. Okay, all right. So that's a mistake right here. I think that should take care of that. Okay, all right. So there we go. We have a solution that is accepted, and now let's try to submit and see if that goes through. Amazing. So that's basically saying faster than 98.70% of C++ online submissions. So that's cool. Everything worked as expected. So before I sign off, I just want to summarize the problem again. Now imagine you were asked this question in interview time frame of 15 to like 20 minutes, and you have to give a shot to this. What problems, what could go wrong? I think one thing that would happen is that you would probably think about ON square solution first. You will start with I and j, and then you will say that if I equal to j, then skip, else you keep basically multiplying. So but then you know what, that will become ON square solution. Now another solution is that you may probably use the idea that he actually suggested here. As you can see, he said that we need a prefix or suffix array. So we may have two more of these prefix vac and suffix vac, and we can build them, and then we have another for loop where we just basically multiply the corresponding elements from prefix and suffix to get our output. But I think this is a very clean solution. It takes a while to wrap your head around it, but basically when you think about it, it's not that hard, because the temp is the element that has the product until the element on which we are. And in fact, the same thing is happening here, except only difference is that this time around, when you have multiplied temp with the desired element in the product vector, you just make sure that you don't override the existing value in the product vector. Otherwise, those two loops almost look same. So with that, I would leave you guys in your happy thoughts of coding, and it's a very, very interesting activity that occupies our mind and keeps us away from a lot of mischief in the world. So with that, I would say adios, and I will see you guys in the next video. Happy coding. Bye bye.